Welcome back, minions. Welcome back here with me, Nick, doing some maths. Got to keep it real. Another MAT question. Here we go. We're keeping them coming at you. Let's get ready for some fun stuff. Again, paraphrasing a little bit, we're going to pop the question up on screen now-ish. Pause that and have a look. But here we go. Roughly, we have in a school 1,000 closed lockers down the corridor. Or this way. We got 1,000 students. They're going to walk down the corridor in order. So student number 1, 2, 3, whatever. Now, the first student will open or close every one lockers. So if they encounter a closed locker, they open it. If it's an open locker, they close it. They just change the open-close status. All right? Student 2 will open or close every other one. So it will go along and lockers 2, 4, 6, 8, it will, if it's open, they will close it. If it's closed, they will open it. Okay, and so on and so forth. The third student will open or close, depending on where it's at, every third locker until all 1,000 students have gone through. So an easy one is the 1,000th student will only open or close the 1,000th locker. Simples. Okay, and that's what's going on. So let's start. All the lockers start closed. How many lockers are closed after the third student? Well, that's easy. Well, it's not easy, but let's go for the first student. After the first student, they are all open. Okay, so after the student, the first student, they are all open. All right, easy. Now, after the second student, well, they are going to close half of them, right? The second student will go along and they're all open. So what he'll do is he will close lockers 2, 4, 6, 8, so on and so forth, right? Now K is 3. Oh, that is, oh dear brain. Come on, you can brain gooder than that. K is 3. Now it gets tricky. Why is that? So, we've got this pattern of open, close, open, close, open, close. Well, what's going to happen? Well, that third person is going to come down, and every multiple of 3, it will either open or close. Okay, but we then have to think out, well, which multiples of 3 are even? Because all the even multiples of 3 will go from closed to open, and all the odd multiples of 3 will go from open to closed. And then we've got to be quite careful, and then we've got a new state to keep track of. So what I suggest is, to get our head around this, let's just write out a few. Let's just write out a few of our lockers. Okay, so locker 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go with that. Okay? Student 1 has gone past, and he's opened all of them. Okay, fine, he's opened all of them. Oh, 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 oh. Student 2 comes along. And now we've got open, closed, open, closed, open, closed, open, closed, open, closed, open, closed. Then student 3 comes along. And like we said, student 3 potters along. You're not a multiple of 3, I don't care. Not a multiple of 3, I don't care. Multiple of 3, I'm going to change you. Don't care, change you. Don't care, change you. Don't care, change you. Now, what we might intuitively have a good sense of is we want to look the pattern every 6. Why every 6? Because every 6, 2 times 3, we have established our full possibilities of multiples of 3. So if we go every 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, all right? And we can see that we get the same pattern, 1, 2, 3, 4, right? And this will repeat, of course, because then we've had our multiples of 3 that are odd and even. We've got all our other options in between. We've got our multiples of 3 that are odd and even, and all the other ones haven't changed. So, right, so every 6 gives us a good pattern. Now, so every 6, we've got 3 open and 3 closed. Yeah, but how many times does a pattern of 6 go into 100? All right, so how many times does into 1,000 even? All right, so 1,000 divided by 6, how many times does it go into it? Well, what's the nearest multiple of 6 to 9,000? So 900 is good, 990 is good. I think 996, right? 996, is it? Is the closest multiple of 6. I do believe. Is that the closest one I can get? Sorry, it's not that. It's 150, 165, 166. This is non-calculator, of course, 166, because 166 times 6 is 996. And we can't get any closer than that. Right. Come on, brain, you can brain good. So what does that mean? Well, I will get 166 of this pattern. I will get this pattern 166 times. All right? So I've got 166 lots of this pattern. We want the number of closed ones, so there are 3 closed in each pattern. Now, what will be left? Well, 996. I've got another 4 numbers after this. I've got locker 97, 98, 99, and 1,000. So the ones we have missing are these 4. All right, so those 4 will provide another 3. So 166 times 3 is 480, 498, plus 3 is 501. So in fact, there will be 501 closed lockers. Smashing. Now, what about we see what happens after the 4th student? Well, okay. After the 4th student, and this is why I've gone up to 12, because I'm a sneaky little rabbit like that, it's every 4th one gets changed now. All right, so O, C, C, O, 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 C, C, O, C. And that should work for me. All right. Now, why have I gone up to 12? Because that should give me my full gamut of multiples of 2, 3, and 4. All the different possibles there between multiples of 2, 3, and 4. So what should happen is this pattern will occur again for the next 12. All right? For next 12. Now we've got 7 opens and 5 closed. All right? 7 opens and 5 closed. Sorry, we should probably label this. So this is part 1. This is part 2. All right? Patterny, patterny, pattern. So now, how many times does this pattern go into 1,000? So we've got to do 1,000 divided by 12. Well, looking at this, we reckon 83. 83. All right, it goes in 83 times. We'll get 996. But just as before, we need the next 4 numbers. So this pattern will occur 12 times, but we need the last 4 numbers to get us to 1,000, so this chunk here will happen again. All right, so we want the number of closed ones. So this pattern occurs 83 times. So it's 83 times. We want the number of closed lockers. Well, there are 5 closed lockers in each sequence, plus the number of closed lockers in this first one, plus 2. So that is 415 plus 2 is 417 closed lockers. Now, this becomes untenable as we look further and further along, right? If I want to see what would happen after the 5th one, and the point is you could try and keep track of this yourself, but it gets harder and harder. You have to think of the multiples of 2, but not of 4, of 2, but not of 4 that are multiples of 3 that aren't, how many times they get flipped. But what we're going to do for the last 2 parts, we're going to do something different. We're going to look at, let's let all 1,000 students go, but we're only going to focus on the 100th locker. And this is actually a little bit easier. So we got locker 100, right? Locker 100 over there. We're just going to think to ourselves, which students are going to flip that door open and shut? Okay? So it starts closed, right? It starts closed. It starts closed. So it starts at closed. Now, which students will open and close it? Well, any student whose number is a factor of 100. All right? Because they each open the K door, so their K has to go into 100. So what numbers will go into 100? 1 will, 2 will, 3 no, 4 will, 5 will, 6, 7, 8, no, because it's the 100th one, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20 will, 25 will, 50 will, and the 100th student. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It will get open and shut 9 times, so it will end up open. And finally, let's do it the other way around. We're going to look at a fixed door, so the 1000th locker, but only what's going on after the 100th student. Same game, right? The 1000th locker starts closed. Which students up to the 100th will deal with them? Well, it's all of these, right? So we've got all of these as well. 1, 2, 4, 5, 10, 20, 25, 50, 100. If you go into 100, if you're a factor of 100, you are also a factor of 1000. And the extra ones, 8 and 40 will go in as well. This takes a little bit of searching, a little bit thinking, but 8 and 40 go in as well. And the other one, 60, no. 3 doesn't go into 1000, so no multiples of 3, no multiples of 7. 8 is 125 times 8, but the 125th student will not touch it because we're only looking at up to the 100th student. Same for 40. Well, no, 40 is the 25th. So, yeah, 40th and 25th, so that'll be cool. So, yeah, so it's these ones. So, it will be open and shut 11 times, so it starts closed. It will end up open. Voila. Did you find that interesting? Please, please, please let us know how you're vibing. How was your summer? What are you looking forward to going into next year? Where you're about? What sort of stuff do you want to see? Let us know. Drop a comment. Also, please, please subscribe and hit the notification so you know when a new one of these things comes out and we can hang out and do a bit of maths together. Awesome. I'm Nick. As always, as yesterday, as before, I haven't changed. I'm still Nick. I'm still doing some maths. We haven't branched out to English yet. I'll see you next time.